In this section, we're going to talk about electrolytes and non-electrolytes and what that means. And so basically what we're talking about is we're dissolving ions in a solution. And because an electrolyte is like, if you think about Gatorade, we say you got to replace your electrolytes. And so you're drinking Gatorade, and Gatorade has sodium and potassium and magnesium and chloride and things like that. So it has all these minerals, or also known as ions. And so an electrolyte is something that can conduct an electric current in water. All right, and in order to do that, you have to have ions present. And so when you put sodium chloride into water, it dissociates into the plus and the minus ions that are its components. So sodium plus, chloride minus. Notice we use the aqueous here because we're saying we're putting that in water. A substance that does not conduct electricity or an electric current in water is called a non-electrolyte. Okay, a non-electrolyte. And so, like if you have H2O2, okay, and you put it in water, it will not dissociate, and so it will not produce ions. And so these neutral molecules of H2O2, hydrogen peroxide, will not conduct because it is not, it does not produce ions when you put it in water. So bottom line is you have to have ions in order to have an electrolyte. A strong electrolyte is one that dissociates completely, or 100% in water, to form ions. A weak electrolyte only dissociates partially in water, and it leaves some in the molecular form that's not charged. And then we said a non-electrolyte is something that does not dissociate. So strong electrolytes produce ions, conducts an electric current, and examples are your salts, sodium chloride, your bases, your strong bases like potassium hydroxide, hydrochloric acid, things like that. A weak electrolyte has a few ions, and so it will conduct a current, but it won't conduct as strong a current as a strong electrolyte. And ammonia, which is a weak base, CH3CO2H, that's an acetic acid, or hydrofluoric acid, those are weak acids and bases. They will conduct, but not nearly as much as a strong acid or base or an ionic compound. A non-electrolyte is a molecule. It does not form ions, therefore it cannot conduct an electrical current. So when we're talking about electrolytes and non-electrolytes, we're going to have to talk about something called an equivalent. And you may hear this from time to time in a medical setting. An equivalent is the number of moles of charge that a mole of ions contributes to a solution. The number of equivalents per mole of an ion equals the charge on that ion. So, for example, if you have sodium forms a +1 ion, so you get 1 equivalent of sodium. Calcium forms a +2 ion, so you get 2 equivalents of calcium. Phosphate is a -3, you get 3 equivalents. So it doesn't matter if it's a plus or a minus, it's how many charges that there are going to be in that solution. So how you use these is if you have an IV with a saline solution, sodium chloride, that contains 154 milliequivalents per liter of sodium ions, how many milliequivalents of sodium is a patient given in 800 milliliters of solution? All right, and this is like a typical nursey type question. So you got 154 milliequivalents per liter of sodium plus solution, and you've got 800 milliliters of the solution, and it wants to know how many milliequivalents of sodium have you given. So first you know that you've got 154 milliequivalents of sodium per liter, and since that is a concentration, you can write it either upside down or right side up. You also know that there's 1 liter, there's 1,000 milliliters in 1 liter, or 1,000 milliliters in 1 liter, either way, right? And you're going to choose the ones that are going to cancel out. So what you can hold in your hand is the 800 milliliters. So that's what you would start this problem with. You've got milliliters, you've got milliequivalents, and you've got liters. So you've got to get rid of liters. So one way to get rid of both of them at the same time is to use the 1 liter is equal to 1,000 milliliters. So if you've got milliliters here, you have to put the milliliters on the bottom. So 800 milliliters times 1 liter over 1,000 milliliters is going to cancel your milliliters. And then times the concentration, which is 154 milliequivalents of sodium in 1 liter. And so that's going to cancel your liters, and it's going to leave you with milliequivalents of sodium. And so in that 800 milliliters, you're going to have 123 milliequivalents of sodium.